What's up, guys? Okay, so today we'll be talking about complex numbers. So remember, check out Khan Academy if you feel like you need more examples or want these topics to learn them more deeply. So, complex numbers, they all revolve around this thing right here, I. Well, okay, you're like, okay, what's so important about I, right? It's just a letter. Well, it's not. In this case, I represents a number. So I squared is equal to -1. Okay, what's so important? That's just a number, right? Well, let's try to figure out what I normally is equal to. So if we get the square, to undo the square, we have to find square root. So we do the square root of -1 and I. So we're left with I is equal to the square root of -1. So there's a problem here. You maybe want, so I don't, some of you guys may know, some of you may not. You cannot find the square root of a negative number, because if I were to square a number, if it's -2 or +3, it's always going to be a positive number. And this is because when you're squaring -2, a negative times a negative is a positive, and when you're squaring +3, obviously a positive times a positive is a positive. So you cannot find the square root of a negative number. So there are some people who might say that I is equal to -1 is wrong, and I'm going to show you their reasoning. So we're going to start with 1. Okay, so what is 1 equal to? 1 is equal to the square root of 1, because 1 squared is still 1. But there is a rule with square roots, and it's where if you have the square root of a product like AB, it is equal to the square root of A times the square root of B. So we can write the square root of -1, or positive 1, as the square root of -1 times -1, because -1 times -1 is +1. So what we can do is we can further break this up into -1, or square root of -1 times the square root of -1. And what do we know? I'm going to move this over here. What do we know about the square root of -1? It is equal to I. So we write this as I times I, right? And that's equal to I squared. And what do we know? What is I squared equal to? It's equal to -1. So what we just concluded here is that 1 is equal to -1. And that's why they say that the square root of -1, or at least I, cannot equal the square root of -1. This is where they're wrong. There's a rule with this square root product property. It's that A and B cannot be negative. So A has to be greater than or equal to 0, and B has to be greater than or equal to 0. They cannot both be negative. One could be negative, like A could be negative or B could be negative, but they cannot both be negative. They could both be positive, but they just both cannot be negative. On the topic of the square root product property, let's do some examples of simplifying negative square roots. So I'll give you 2 examples right here. See if you can work them out on your own. We have the square root of -49 and the square root of -40. So let's start with this first one, okay? With the square root product property, that's just what I'm calling it now, we can break this up into 49 times -1, because I was telling you 1 could be negative, but they cannot both be negative, okay? So we can break this up into square root of 49 times the square root, these are bad square roots, okay, just ignore that, -1, okay? So we know the square root of 49 is 7, and the square root of -1 is I. So look at that. We just found a solution to a seemingly impossible problem. Now let's move on here to the square root of -40. So there's a few ways we can go about this. So let's start with breaking it up into the square root of 40 times -1, right? Because only in this case only b, or whatever you want to call it. Negative 1 is negative, okay? So we're going to break this up further into 40, the square root of 40 times the square root of negative 1. But look at this. 40, it's not a perfect square, but within it there is a perfect square. So we can break this up into 4 times 10 times square root of negative 1, and we know that the square root of 4 is 2, so it's going to be 2 times the square root of 10 times I. And that's our solution. Okay, so let's talk about the very circular properties of I, okay? So let's work with the powers of I. So what is I to the first power? Well, we all know, right, like just right here, the I to the first power is the square root of negative 1. Okay, well then what's I to the second power? I to the second power is negative 1, right? Because square root of negative 1 times square root of negative 1 is, oh, it's not negative I, it's negative 1, okay? Well, now, what's I to the third? This is might be more of a confusing question, but it's very simple. We're just going to multiply I to the second by I to the first. So, what's negative 1 times the square root of negative 1? But we also know that the square root of negative 1 is also I, so we can just multiply negative 1 times I. So, that leaves us with negative I, okay? So, we know that this is negative I. And to just simplify in the future, we can just write square root of negative 1 as I. I to the first power is I. Okay, simple. So we have I to the first is I to the second is negative 1, and I to the third is negative I. So let's see what I to the fourth is. Okay, well, how can we do this? Well, we can basically just multiply I to the second times I to the second. Just keep it simple. Negative 1 times negative 1 is equal to positive 1, okay? So we have this right here, this set. It's going to be very important in the future. Let me just box that, it's going to look cool. So now let's move on. I'm going to start over here, I to the fifth, okay? So how it works is I to the fifth is just going to be I to the fourth times I to the first. And what's 1 times I? 1 times I is going to be equal to just I, okay? Now what's I to the sixth, okay? Well, I to the sixth could just be I to the fifth times I to the first, right? And we know that it's equal to I squared, right? I times I is I squared. And what's I squared equal to? Negative 1, okay? Now, what's I to the seventh? Well, I to the seventh is just I to the sixth times I to the first, okay? So what's negative 1 times I? Negative I. I to the 8 can be written as I to the seventh, negative I, times I to the first. And we know that's going to be negative I squared, and we know that I squared is equal to negative 1, so it's equal to positive 1. Now, do you see a similarity right here? It's a cycle. I to the first is I to the second is negative 1, I to the third is negative I to the fourth is 1. And it's the same thing over here. I to the fifth is I to the sixth is negative 1, I to the seventh is negative I, and I to the eighth is 1. So it's a cycle, and it's a very important cycle here. If the I is to a power that has a factor of 4, it's going to be equal to 1. Okay? So that's the very circular property of I. Now that we know that I kind of forms, the powers of I form a cycle, let's try to figure them out, okay? So I'll give you 2 examples right here, I to the 60th and I to the 41st. That was bad 4. So let's look at this. So I to the 60th, we know that if the power, or that I is raised to, has a factor of 4, it's going to be equal to 1. Does 60 have a factor of 4? Yes, 60 can be written as 15 times 4. And what do we know about exponential properties? We can write this as I to the 4th raised to I to the 15th. And we know I to the 4th is 1, so we could rewrite this as 1 to the 15th, and we all know 1 to any power is equal to 1. So I to the 60th is equal to 1. Now let's look at this. 41 is not a factor of 4, but let's try to find the closest factor of 4 below it. So obviously, as you can see here, it's 40, right? So this is going to be, we can write this as I to the 40th times I to the 1st, because when you multiply to the same bases to an exponent, you just add them, okay? And we can write 40 as 10 times 4. So we can rewrite this as I to the 4th, which we know is 1 to the power of 10 times I, okay? So then here, 1 to the 10th power, it's 1 to anything is 1 times I. And anything times 1 is the thing, right? So 1 times I is I. So we just found that I to the 41st power is I. Thanks for watching, guys. This video ran a little long. I had to cut it here. Next video we'll be discussing what complex numbers actually are and something called the complex plane. Peace.